So Haptic devices came out of MIT in the late 90s, and the creator was working in the robotics lab and basically thought, if I can use a computer to tell a robot arm to move, couldn't I use a robot arm to manipulate data within the computer? So the Haptic device is basically a reverse robot. And then they started building the Haptic devices and deciding what they should do with them. And one of the first things that popped up was 3D modeling. So they created a program to create 3D shapes within the computer, almost like working with clay or virtual clay. So you could feel it and touch it and sculpt it into the shapes that you wanted. The Touch X, we sell an SDK to research institutions and developers to create their own apps. So some great uses from the development kits that we sell are surgical, a lot of medical simulations. So being able to simulate different tissue densities so that surgeons can practice before they go to the surgical theater and actually cut. They can practice the procedure many times. Those are some of the most exciting examples that I've seen, but there's another one was for kind of part validation. So if you need to take a tool that's this size, and you know that once this object is assembled, in order to reach this nut or this screw, you're going to have to reach through and around the corner and see if you have the clearance. So we've seen development kits where people can actually pick up the tool and then take a CAD model and try to see if does this fit through there, and can we unscrew it? Once this thing is made, will we be able to repair it without having to take the whole thing apart? So it gives a real world experience to CAD data, so you can avoid costly mistakes where you make something and realize we have to take this whole thing apart before we can work on it. So that's another interesting example. So we've been having a lot of requests lately for people to get scans of themselves, and we created a software that uses the Kinect or the Kinect-like sensor to be able to capture and create your geometry with full color that we can then bring into the computer and sculpt in that way. So what you experienced when we sat you down and spun you around was the computer capturing the data, and then I can bring it in and convert it to voxel, and then we can interact with it. There's a lot of different technologies with capturing, so 3D scanning. Photogrammetry is a popular one that we see, where you can take a series of photos and turn those into a 3D object. Depending on the camera and the way it's positioned, how many lenses, how many images you take, you can get different qualities. With the Kinect sensor, we are limited to the hardware that's in there, and that hardware currently was designed for the game, recognizing movements of a human body. So it's really perfectly suited for human scale. Works really well for that. Whereas if I wanted to scan a mechanical part, the Kinect wouldn't be appropriate for that. And there's industrial scanners on the market that we use that can give us much higher resolution and fidelity. As a designer, Touch has really changed the way I create. There's lots of different design softwares on the market, from 2D design packages like Illustrator and Creative Suite to 3D surface modeling, poly modeling, kind of Pixar type, subdivisional modeling. It gets pretty technical. With the power of touch, you can kind of leave that behind, just touch it and grab it. Like, I want this over here now. And I can just take it, feel it, and pull it over. So it plays into that democratization bit and opening up the possibility of 3D to a lot more people. I've trained myself a lot better at sculpting through taking other people's models and seeing how they did it and watching, feeling how they did it. You get to put your hands almost where the sculptor had his hands. You can feel those curves and the way that his hand moved across the surface. And, because you get a sense for the way that it's constructed.